Hi everyone, and welcome to the video presentation for Module 18. This module will be talking about enharmonic modulation. So as we go through this video, we will review the idea of enharmonic equivalence, which we haven't talked about in a while. Then we'll define the term enharmonic reinterpretation. Then we will be able to identify chords, which the book also calls sonorities, which just means sounds. Which one of those can be enharmonically reinterpreted to create an enharmonic modulation. So before we can talk about modulation, we need to talk about enharmonic equivalence and remind ourselves exactly what that is. So enharmonic equivalence is the idea that more than one note can be used to notate the same pitch. For instance, a G sharp sounds like this, but an A flat sounds like this. So they're the same pitch, but you can write them as you can write that pitch as either a G sharp or an A flat on the staff. So it's two different notes, but they refer to the same pitch. Another one is a C natural, which sounds like this. That's enharmonically equivalent to a B sharp, which sounds like this. Again, the same pitch, but you can use two different notes to represent that pitch. An E flat sounds like that, and it is enharmonically equivalent to a D sharp. Okay, so that's enharmonic equivalence. Now, there's a couple reasons why a composer may choose to spell something as one note or another note. So in other words, why they would choose one enharmonic spelling as opposed to another. And one reason would be to more clearly show the direction a pitch will move. So let's say we have a note G, and we want to show that that is moving downwards. In order to make it look like it's moving downwards on the staff, it's much clearer to write the lower note, below it, as an F sharp as opposed to a G flat, because you can see F sharp actually moving down on the staff as opposed to a G flat, which would look like it is staying on the same line on the staff. So that's one reason. Another is to make the music easier to read. So especially in sort of the late Romantic period, very chromatic keys and modulations would kind of get out of hand. So there are a lot of instances where a composer may be modulating to a crazy key like C flat major. It's a lot easier to read C flat major as B major. So a composer may choose to rewrite that entire passage in the theoretically incorrect key of B major, but it would be a lot easier to read as B major as opposed to C flat. Okay, and then the other reason to do it would be to create an enharmonic modulation, which is what we're going to talk about in this video. So enharmonic modulation involves a process called enharmonic reinterpretation. And that's just the respelling of a chromatic pivot chord, so a chord that it would exist in both keys, so that it functions, or resolves in this case, in the new key of a modulation. So for instance, here, this is the key of C, and we start off with this, looks like a first position F chord, so 4 chord, which moves on to the chord that's being pointed at there, which looks like a German augmented 6 chord. And this is all, of course, in the key of C major. And written this way, we would expect that F sharp on the top of that augmented 6 chord to resolve up by a half step to a G. And of course, the A flat in the bottom of the chord would resolve down a half step to the G. So that's a standard resolution of a German augmented 6th in the key of C major. So we know how that works. Okay, so that gives us our 4 augmented 6 and then a 1-6-4, like it should. But it's also possible to rewrite that middle chord, that German augmented 6th, so that that F sharp is now a G flat. And if you look at that chord now, it doesn't look like a German augmented 6th anymore. It looks like a dominant 7th chord. But it sounds the same. So all we've done is respell one of the notes so that it looks like a 7th chord and not a augmented 6th chord. Okay? Which means we can use this chord now as a 5/7, and we've rewritten it so that it looks like it should resolve the way that a 5/7 should resolve. So now that G flat on top, since that's the 7th, it no longer has to resolve up to a G, it will resolve down to an F. And that C in the middle of the chord is the leading tone, it will need to resolve up to a D flat. So we've created a chord, right, using the exact same pitches, but we've just rewritten it so that it functions as a 5/7 in the key of D flat major, as opposed to a German augmented 6th in the key of C major. And this opens the door to getting to different keys that we otherwise wouldn't be able to get to. And like I said, these are the exact same sound. They both sound like this, but one would resolve like a German augmented 6th, one would resolve like a 5/7. And the book, you might not remember, we didn't go over this too much, but the book calls this sonority, this sound, a major minor 7th chord. Okay? So any modulation that uses this idea of enharmonic reinterpretation is called an enharmonic modulation. Okay, so there are 4 sonorities or chords or sounds that can be enharmonically reinterpreted. One is the one we just saw, which is a major minor 7th chord, and that can be interpreted either as a 5/7 or as a German augmented 6th. Another harmony that can be interpreted in a lot of different ways is a fully diminished 7th chord. Another one is a French augmented 6th chord. And the only other one is the augmented triad. So all 4 of these can be respelled, reinterpreted to be different chords in different keys. And the most common are the major minor 7, which we just talked about, and the fully diminished 7th chord. So let's talk a little bit more about the dominant 7th being reinterpreted as a German augmented 6th chord. So this major minor 7 sonority can be enharmonically interpreted as either a German augmented 6 or any 5/7 chord. So it could be the dominant of the key, but it could also be a secondary dominant. It doesn't really matter. It can be interpreted as any 5/7 chord. So here's an example of how this works with a 5/7 that's not necessarily the dominant of any key. So here we have a progression in the key of D major, and that first chord is a 1 chord in the key of D major. Then our next chord is that B7 chord there, which you could analyze as a 5/7 of 2. And you would expect that to resolve to the 2 chord, the E minor chord. But you can see in this progression, it doesn't do that. Instead, it resolves to what looks like an E flat 6/4 chord. All right? So obviously, this is some kind of modulation. So this 5/7 of 2 is being enharmonically reinterpreted as a German augmented 6th in the key of E flat major, and resolving to a 1/6/4 in that key of E flat major. So this is a case where we're reinterpreting this chord as 5/7 of something, right? Any kind of 5/7, and using it as a German augmented 6th in the new key. Now notice that the pivot chord isn't written so that there is an augmented 6th, but it resolves like it does. So this is a common thing too. The reinterpreted chord won't necessarily be rewritten as the new chord, but it will resolve or function as the new chord should. So you can see that even though we have a 7th between that B and that A, that 7th doesn't resolve down by step, right? And the leading tone doesn't resolve up by step. Instead, that what looks like a 7th resolves outward by half steps, just like an augmented 6 chord does. So what's important is not necessarily how the reinterpreted chord is written, but how it resolves. So reinterpreted chords will resolve as they should in the new key of the modulation. Another thing to notice there is that we have a D sharp in that middle chord and an E flat in the next chord. In real music, that would probably never happen because those are the same note. So for ease of playing, that D sharp would probably be rewritten as an E flat, and you just have some weird chord in the middle there. So another thing to note about enharmonic modulations is that things won't necessarily be rewritten functionally, but they will resolve functionally. Okay, let's talk about the fully diminished seventh chord, the other common kind of chord that is suited for enharmonic reinterpretation. And what makes this chord special is that it is completely symmetrical. So unlike most other chords, the fully diminished 7 is symmetrical, which means that the notes of the chord are all the same distance from each other. And if we look at a fully diminished 7th chord, you'll see that here we have an E as the root. Then we go up a minor third to get to G for the third, up another minor third to get to the 5th of the chord, and up another minor third to get to the 7th of the chord. And if we went up another minor third, we'd end up on a note that sounds like E again. So this chord is made completely of minor thirds. So it is symmetrical, which means that there's no reason, no structural reason, that one of these notes has to be the root of the chord. So like in a major chord, the reason we know that something is the root is because it is a major third, right, below the third, and it's a perfect fifth below the 5th, right? So that defines the sound as a major triad. Same with a minor triad. There's a structural reason that something sounds like the root. But with a symmetrical chord like this, there's no reason to not hear that bottom note as the root, right? Any of the notes in this chord can be the root of the chord. And since it's a leading tone chord, that means that any of these notes can be the leading tone of a new key in a modulation, right? So with this chord here, that E could be the leading tone of F, right? So this chord could lead to F. That G could be the leading tone of A flat, and so on. So since all these notes can be the leading tone of the chord, any fully diminished 7th chord can lead to 4 different tonics. Okay, here's that same chord. Now this is how the chord should function in the key of F minor. So we have a 1 chord at the beginning of this progression, followed by our 7 fully diminished, which should lead to the key of F minor again. So that's a closed progression. There's no modulation happening here. But what happens if we rewrite that that E natural as an F flat? Now we have the same notes, right? We still have what sounds like an E natural, but it's an F flat this time. To a G, to a B flat, to a D flat. It's the same notes, but we've rewritten it so that it looks like a 7 fully diminished 4/2 chord. And we've written it in such a way that it needs to resolve to the key of A flat. And I've picked A flat major, but it could also be A flat minor, right? Right, so here's the progression, starting in the key of F minor, going to our fully diminished 7th chord, and now resolving to A flat instead of F. We can rewrite this another way too. We can change those flats into sharps. So now we have E natural, G natural, A sharp, C sharp, all the same notes. But now that respelling it makes this a 7 fully diminished 4/3 chord. And the root of this chord now is the A sharp. So that should lead to the key of B. And I've picked B minor here, but it could also be B major. So that's another key that this fully diminished 7th chord could lead to. So if we listen to that modulation, we start on F minor, go to our fully diminished 7, and now we resolve to B minor instead of F or A flat. And you can hear that they're all equally convincing, right? That's because those same notes work the same way in all of these keys. So the last way you could respell it is to make that D flat into a C sharp. And so now we have a chord that has the leading tone of C sharp. So this is now a 7 fully diminished 6/5 chord, right? And so since now C sharp is the leading tone of the chord, and I haven't changed any pitches, right? I've just respelled things. Now that C sharp is the leading tone of the chord, this functionally looks like it should lead to the key of D. And I picked D major, but it could also be D minor. So that's another key that this can go to. So there's a lot of cool stuff you can do with fully diminished 7th chords as far as like getting to crazy keys. You can see that that one 7th chord can lead to the key of F, the key of A flat, the key of B, and the key of D, just by respelling it, right? So we didn't change any pitches, we just respelled the notes so that they look like they need to lead in different directions. And then one last thing about the 7 fully diminished is because of enharmonic equivalence, there are only 3 unique fully diminished 7th chords in our system of 12 notes. And so I can kind of prove this. So here's a fully diminished 7th chord built on a C, which consists of the notes C, E flat, G flat, and B double flat. If you went up a half step and built another 7th chord, fully diminished 7th chord on C sharp, we'd have C sharp, E, G, B flat. Those 2 chords have entirely different notes. So they don't share any notes. So those 2 are unique from each other. If we went up another half step, we would have D, F, A flat, C flat. Again, those are all 3 different notes than the other 2 chords. So, you know, all of these 3 chords are completely different from each other. They don't share any notes. But if we go up one more half step, we get a chord built on a D sharp. Well, D sharp is the same note as E flat, and F sharp is the same note as G flat, and A is the same note as B double flat, and C is in that same chord as well, a C, right? So these 2 chords actually have the same notes. So because they're all enharmonic equivalent, these 2 chords are the same chord. So you can see that there are really only 3 possible fully diminished 7th chords. Now I could keep going with this to prove it even further. So we could build a fully diminished 7th chord starting on an E, and you can see that the second chord we built had an E already, it had a G already, it had a B flat already, and then C sharp and D flat are the same note, so those chords also have all the same notes. So now we're starting to repeat ourselves. So those 2 chords are actually equal. And then if we spelled something on a half step higher than that, we'd have F, A flat, C flat, E double flat, which are the same notes in the other chord, D, F, A flat, C flat. Those are all the same. So those chords repeated as well. And you can keep going up half steps, but you're just going to get the same cycle of 3 different fully diminished 7th chords. So just something interesting to note about that. All right. Well, that is enharmonic modulation. If you have any questions, we can go over it in the Zoom session. Other than that, thanks for watching and have a great day.